Hi there, my name is Mitch and this is yet another video of my series of videos focused entirely on the AP Precalculus syllabus. In this particular video, which goes by the topic inequalities with polynomials, we will focus more, and that will be done in a short and quick way, we will focus on how to properly geometrically solve inequalities. And what do I mean about from that? I mean, when given the graph of a function, when given the graph of a polynomial in our case, how we can actually use that graph to solve a given inequality. Remember two key things. When we refer to f of x, we have seen that in the root. We have seen the geometrical interpretation of a root. When we have something like that, f of x equals 0, this geometrically means the points at which the graph cuts the x-axis, the horizontal axis. So f of x is 0 means the graph intersecting the x-axis. Similarly, f of x greater than 0 means all those points for which the graph is above the x-axis. And finally, f of x less than 0 means all those points, all those input values, all those x values for which the graph is below the x-axis. Once again, f of x equals 0 means where the graph is exactly on top of x-axis, where it intersects the x-axis. F of x greater than 0 means when the graph is above the x-axis. And finally, f of x less than 0 means when the graph is below the x-axis. Let's use all this concept for the next example. We clearly have a graph in front of our screens. In A, where does f of x is 0? Well, we can see from the graph that it is 0 at -3, at -1, and at 3. In B, where is f of x greater than 0? Let me highlight that. It's greater than 0 from here and there. So it's greater than 0 between -3 and -1. I'm not going to include the endpoints because it doesn't say greater or equal. It strictly says greater than 0. So from -3 to -1. And from 3, again, not included, up to plus infinity, assuming that the graph keeps extending. Where is f of x less, smaller than 0? It should be here. And there. So it is from minus infinity up to -3. I'm not going to include -3 because it doesn't say f of x smaller or equal than 0. And this time I'm going to use the correct mathematical notation, which is from the union. This is called union. -1 up to 3. Finally, in D, there is a question that combines what we are now learning with some previous knowledge. Where is the rate of change positive and increasing? Remember that a rate of change positive means that the graph itself is increasing. A rate of change negative means that the graph is decreasing. A rate of change increasing means that the graph is concave up, and rate of change decreasing means that the graph is concave down. What do we want now? The rate of change positive, so we want that graph to be increasing and increasing. So basically, we need to scan the graph and find out when that graph is increasing and at the same time concave up. So by looking at it, and remember that concave up means when it looks like a cup, it is concave up in this highlighted by green. And the increasing part of that would be, I would say, just from here, let's call that from 1.5 up to, assuming that it extends like that, up to plus infinity. And there it is. I hope this video helped you to understand how to geometrically solve an inequality. If you think the same, don't forget to like and subscribe. As always, thank you for watching and thank you for your time.